Hi, count subarray with fixed bounds. You are given an integer array nums and two integers min k and max k. A fixed bound subarray of nums is subarray that satisfy the following condition: the minimum value in the subarray is equal to min k. The maximum value in the subarray is equal to max k. Return the number of fixed bound subarrays. A subarray is contiguous part of an array. Example, here we have the array 1 3 5 2 7 5. Min k is 1, max k equal 5. We need to find all the subarrays that the elements in that subarray is between 1 and 5 inclusive. So the answer will be two subarrays. So the first subarray is 1 3 5, which is 1 3 5. You notice the minimum on this subarray is 1, the maximum is 5, and all the elements in the range between 1 and 5. Also, this subarray 1 3 5 2, the min is 1 and the max equal 5. So we have two subarrays and the answer will be 2. For this array, the answer will be 10 because all the subarrays meet the condition for min k equal 1 and max k equal 1. For example, this is subarray that has min equal 1 and max equal 1. This one also 3 elements, this one is 4 elements. This one also, this subarray, and this one, and this one. So we have 10 subarrays. Here are the constraints. The length of the array is less than or equal 10 to the power 5, and the value of num of I and min k max k less than or equal to 10 to the power 6. How can we solve this problem? Of course, we have this number of elements. It means that we need a better algorithm than n square. So let's see this example. We have 1 2 1 3 5 2 1 3 5 2. We have 7 5 min k equal 1. Then we have max k equal 5. So the idea is we need to calculate the number of the subarrays for that starts at each index of the array, and we accumulate the result at the end. So we will count all the subarrays for this index, then we'll count all the subarrays that meet the condition for this one, then for this one. And to do that, first of all, we need to know for every index what is the next element that is outside the range of the min and max, which is less than the min or greater than 5. For example, for 1, the next element is 7. 7 is greater than 5. 7 is at index 0 1 2, this is 1 3 4 5. So, and here we have 6, which is outside the array. So index 7 is at or the value 7 is at index 4. And for 3, we also have 7, which is out the range. All the elements here are inside the range. So for 3 we have 7, which is at index 4. For 5 also we have 7. For 2 we have 7. For 7 also we have it this index. And for 5 we don't have element because the 5 itself is inside the range, so we store the index 6. How can we calculate this out of range index? To do that, we will loop from right to left for the element 5. The element 5 itself is inside the range, so we will store 6. It means the elements is outside the array, that is out of the range, or it means exactly there is no elements on the right side of 5 that is out of the range. 7, the 7 itself is so in the vector we will store 6. In 7, the 7 itself is outside the range, so we will store the index, which is 4. Now 2 is inside the range, then we will store this element here, which is the value in I plus 1. For 5 is inside the range, so we will store also 4. For 3 we will store 4. For 1 we will store 4. Now we have the out of range vector. Next, what we want to do is for every element, and for while looping against all the elements, we will store the indexes where the min and the max exist. So we have set of elements. Set is sorted set in C++. So this set, call it min k set, and we have max k set. We will store the indexes of occurrences of the values min and max. So here we have 5, so we'll push to the max the index 5. Also we have 5 at index 2, so we have index 2, but this should be sorted, so 2 then 5. And then we have 1 at index 0, we will push it to this set, so the set will have the value 0. So now we have the min k set, we have the max k set, we have the out of range vector. Then we will loop from, or we will iterate over the array from left to right for every index. First of all, we need to find the index which is out of the range using this array we calculated previously. So for 1 we have the value 4. We have the value 4 for out of index. Then we need to check here using binary search the first occurrence of the min k. In this case it's 0, and we need to check here the first occurrence of the 5. In this case it's 2, so we have 2. So we have 4 out of the range, we have 0 for the min, we have 2 for the max. After that, so we know this value, and we know this value. The number of subarrays will be so here we will have 0 and 2. We take the max, which is 2. Here is 2. The number of subarrays for this index will be starting from this, then this, until we reach the out of range index we have. So the value will be out of range index, which is 4, minus the max of these two, which is 2. So there are 2 subarrays for the index, the first index. So we have 2. Then we will move to the next next index in the array. We do the same calculation. We add the result here. Then we do this for the next element, and so on. Let's see the implementation. As we said, first of all, we need to calculate the next out of range vector, and we need to store the max indexes and the min indexes in a set, in 2 sets, so 2 different sets. So here we loop from right to left in nums array, and if nums of I equal min k, push the index to min k indexes. If it's equal to the max k, push it to the max, push I to the max indexes set. Now here we are calculating the out of range values. So as we said, if num of I is greater than max, or if it's greater of, or if it's less than min k, then it means that this element is out of the range. We need to insert it in so in this vector, so it's equal I. Otherwise, take its value from the elements in the right. Now we are done with the indexes and with the set of location and the out of range vector. Now we need to loop over each element from left to right. We will store the answer in this variable. First of all, we need to know the index of the out of range for this item. Then using lower bound function, we can know the first element or the first index that has min k. Then after that we need to find the first max k, first index that has max k value. Now if the first min is greater than NO, or if NO is less than the first min index, or NO is less than the first max k, continue. This means that let's say here we have 1, 5, but if the 7 is between here, so the condition will break. We'll have only 1, we don't have the 5. This is why here we need to check if out of range index is less than min k or less than the first max k. We'll continue. Otherwise, accumulate the result. The number of subarrays for this index is NO minus the max of the first min k and the first max k. Time complexity for this, we have this loop, which is big of n. We have insertion to a set, which is big of n log n. By the way, you can we can convert this to an order set. The time complexity will be constant in average. Instead of log n for insertion. So for this it will be big of n. For this loop, we also have big of n.